this is the numerical. Now we will try to write down its given data. So look at the numerical and try to write as an open cycle gas turbine plant uses heavy oil as fuel. The maximum pressure and temperature in the cycle are. Okay, so this is try to draw the first cycle diagram so that you can try to do TS diagram. So how the TS diagram will come? TS diagram will be like this. Okay, all of you look at here. Now this is what? Minimum pressure. P minimum and P maximum. Only two pressures are there. Okay, so cycle will be, isentropic cycle will be like this. 1 to 2, 2 to 3, 3 to 4. Ideal cycle, right? Okay. So from this, here you can also write P1 and P2. Okay. So the maximum pressure of the temperature in the cycle, maximum P max to P2, which is equal to P3, which is equal to 5 bar, because the pressure is constant, right? And maximum temperature is how much? T3, which is 650 degrees centigrade. Even how much it is? 650 plus 270. How much? 923 Kelvin. Right? Okay. Then next, temperature of the air entering into the compressor means P1, which is equal to P4, which is equal to 1 bar. T1 is how much? 27 degrees centigrade is equal to 27 plus 273. How much? 300 Kelvin. Okay. The exit pressure is also 1 bar. Right? Efficiency of compressor and turbine. Compressor efficiency is 80% and turbine is 85%, right? And what we need to calculate? Thermal efficiency. Okay, thermal efficiency needs to be calculated, and other values are given. Cp for air and gas is 1 kilojoule per kg Kelvin, and gamma is equal to 1.4 for both air and gas. This is data, right? So as efficiency is given, means 1 to 2. This is the isentropic process, and 1 to 2 dash is the actual process. Similarly, 3 to 4 is the isentropic expansion in the turbine, and 3 to 4 dash is the actual expansion, right? We know temperatures at T1, 3, that we know. Okay, so we can calculate T3. How we can calculate T2? How to calculate T2? Already we have seen how to calculate T2. 1 to 2 is isentropic process. Calculate process 1 to 2. T2 by T1 is equal to P2 by P1 raised to gamma minus 1 by gamma. So T2 P2 how much? P1 is 300. P2 is how much? P2 is 5 by 1. 5 by 1 raised to gamma minus 1 by gamma. That is 1.4. Take gamma 1.4 and from this, tell me the T2 is 475.17 Kelvin, right? Now how to calculate T2 dash? From the efficiency, okay? From the efficiency of compressor. What will be the efficiency of compressor? Output divided efficiency is what? Efficiency is always less than 100, right? So numerical will be smaller. So T2 minus T1 divided by T2 dash minus T1. T2 minus T1 divided by T2 dash minus T1. So compressor efficiency is how much, which is given 0.8. T1 is 300. So T2 dash minus 300. So from this T2 dash we can calculate how much? 518.95 Kelvin, right? Yes. Now next, they have asked efficiency. So for efficiency, what is required? Yes, shaft work divided by heat supply. Shaft work is equal to turbine work minus compressor work. So we need to calculate compressor work, right? So how to calculate compressor work? Compressor work. How to calculate compressor work? Compressor work per unit 1 kg of air supply or 1 kg air means per kg, right? So MCP into T2 or T2 dash, actual T2 dash minus T1. So M is 1, CP is also 1, T2 dash 518.95 minus 300. This work of compressor is equal to how much? Tell me. 218.95, right? Combustor. Now in combustor, air mixture gets mixed and combustion happens. So what is the mass of gas is equal to mass of air plus mass of fuel, right? Now air fuel ratio, okay? So divided by mass of air by mass of fuel plus 1, right? So air fuel ratio is how much? 60 by 1 plus 1. Mass of the gas is how much? 61, sorry. 61 by 60, right? That is your mass of gas, kilojoule per kg, right? Now next, 61 by 60. See, air fuel ratio is 60 as to 1 is given. So from this mass of the gas in this one, air will come in the combustion chamber, fuel will get added, and combustion will take place. Whatever the gases are coming out, that will be equal to mass plus mass of fuel. That is what mass of the gas is equal to air plus mass of fuel. Now I have divided mass of fuel here. So mass of fuel divided by mass of fuel plus mass of fuel divided by mass of fuel 1. I know mass of air fuel ratio 60 as to 1. So that will be 61 by 60. No. Yes. We have divided by mass of fuel on one side only. Whenever we do any mathematical operation, we have to do it on both sides, right? Yes. Yes. Now to get this, mg by mf is equal to ma by mf plus 1. Okay, so put this value, it is 60 plus 1. So mg means what? mg by mf is equal to 61. Okay, now this mg is equal to 61 multiplied by mass of fuel, right? So for mass of fuel I can write mg is equal to, take mass of air common, or mass of fuel common, plus 1. Okay, so mf into, sorry, don't take mf common, take ma common, because we don't know mf, we know ma, so take ma common, 1 plus mf by ma. So ma is how much? 1. Now air fuel ratio is 60, so fuel air ratio is 1 by 60. So we will get 61 by kilojoule per kg. Kg per kilojoule, right? Kg per kilojoule. समजलं का हे? ma is not 60. Mass air fuel ratio, right? So fuel air ratio is 1 by 60. That is what I have taken. 1 plus 1 by 60, which is 61 by 60. That is the mass of gas. Okay, kg per kilojoule. Okay. Now next we require heat supply. Heat supplied in the component is what? Enthalpy heat supplied in the combustor, that is H3 minus H2 dash. H3 minus H2 dash. So H3 is what? After combustion, mass of the gas into Cp into T3, right? Minus H2 dash. At the H2 dash, mass of the air, Cp of the air into T2. Understood this? Yes, समझ का? So, right? So heat supplied is equal to mass of the gas. How much? 61 by 60. Cp is 1. T3 is how much? 923 minus mass of the air 1. Cp 1. T2 I18.9. So from this, heat supplied in kilojoule per kg. What is the value of heat supplied in kilojoule per kg? How much it is? 419.43 unit kilojoule per kg. Turbine work, right? For turbine work, now to calculate the turbine work, actual temperature should be known at the outlet of turbine. At the inlet of turbine, temperature is known. Temperature, the theoretical temperature at the outlet, that is also known. Okay, so how to calculate the actual temperature? By using the efficiency formula. I know T3. Okay. Right. So the efficiency formula for turbine will be numerator is smaller, denominator is bigger. So T3 minus dash divided by T3 minus T4. Efficiency is a formula in terms of temperature. Less than 100%. So smaller, denominator is bigger. Right? इथं बघून समजतंय तू T4 is bigger, right? Turbine efficiency is equal to T3 minus T4 dash divided by T3 minus T4. T is given, T4 is not given. So first calculate the T4, right? So process 3 to 4 isentropic expansion, right? So T4 by T3 is equal to P4 by T3 raised to gamma minus 1 by gamma. So T4 is equal to T3 is given how much? 923. P4 is 1. P3 is 5 raised to 1.4 minus 1 by 1.4. So T4 is how much? Calculate it fast. Okay, so the T4 is 580.76. So from this, put these values in efficiency formula. What is the efficiency for turbine? 0.85 equal to T3 923 minus T4 dash, that needs to be calculated, divided by 924 580.76. 76. So from this, T4 dash is equal to, calculate T4 dash. T4 dash is 680. 3.79 Kelvin, degree Kelvin. Okay. Now next, what needs to be done? Turbine work. What is the formula for turbine work? Tell me the formula. Mass of the gas, correct. Cp of the gas multiply by T3 minus T4 dash, right? So what is the mass of gas? 61 by 60. Cp1, T3 923, T4 dash 633.79. Okay. So turbine work is equal to, tell me, turbine work is equal to 293.8 kg. So shaft work is equal to turbine work minus compressor work. That will come 293.8 minus compressor work is how much? Compressor work to 18.95. To 8.95. Okay. So calculate the shaft work, and efficiency is equal to, thermal efficiency is equal to shaft work divided by heat supplied. Heat supplied is 419.43. 419.43, and shaft work is how much? Something is wrong here, huh? Never check it correctly. 4. Okay. Yes, it is correct. Yes. Shaft work is how much? 75.08. Okay. 75.08. From this, thermal efficiency much? 17 point something percentage. Understood this numerical, right? So calculate temperature, actual temperature, compressor work, heat supplied, and turbine work. And from turbine work, shaft, and then efficiency, right?